Good morning, everyone, and welcome back to the physics class. We were dealing with ray optics, and I think in the previous lecture we had completed reflection by a plane mirror. Now, reflection by a plane mirror was very simple. We'll now have to move on to the next topic, which is reflection by a spherical or a curved mirror. Now, remember, beta, this chapter is all about definitions. It's all about understanding the terms that are going to come. Now, if you can understand those terms, well, this chapter is going to be very, very easy. And in this year's JEE Advanced, there were I think, 7 or 8 questions coming from this particular topic. 4 of them coming in a matrix match type. They have 4 questions over there. So you had to match the options. I'll show you that question as well when time comes, because right now that question was from lens. I showed you 2 questions from last year. It was one was pure reflection, 3 plane mirrors. The other one was a curved mirror and an object moving towards it. We will come to that, but for that we will have to understand the next heading, and the next heading is spherical mirrors. I hope everyone is noting it down together with me. Spherical mirrors or curved mirrors. Now, what is going to be the difference between the two mirrors? The first one was a plane mirror and the second one is spherical mirror. In plane mirror, you have a flat surface like this. One side is painted, so nothing goes on the other side. This is the side that is painted. I hope you all remember this. And the red side is the side which is polished, or which is the glass, and reflection takes place from the red side. Now, if I curve, if I draw this mirror like this, or if I draw it like this now becomes this mirror now becomes a curve or a spherical mirror. I hope all of you understand this. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir. Now here, same thing. These two are the painted surface. The black surfaces are the painted surface, so that nothing goes on the other side. And the red ones are the one which are used for reflection. Now, there are 2 types of mirror that we are going to see in this spherical mirror. One would be concave and the other one would be convex. We all know this, yes or no? We all know this, yes or no?
Yes, sir.
Yes,
Yes.
sir.
Now, before going into concave and convex mirror, we must understand why they are known as spherical mirrors. Can anyone tell me? And I know you must be knowing it, why they are known as spherical mirrors. Anyone? Why these mirrors are known as spherical mirrors?
They are part of a sphere.
They are part of a sphere. That is correct. So that is the first point that you would write. And point number 1 is spherical mirrors are nothing but part of a sphere. Can you see this sphere here? Can you see this sphere here? Yes,
Yes,
or
sir.
no? Okay. Now, as I told you, this chapter is all about definitions. So let us first understand some definitions of this spherical surface. As you can see, there is a spherical surface. What is this thing in yellow?
Center of curvature.
That is the center of the sphere. Yes or no? This is the
Yes, sir.
center of the sphere. This is the center of the sphere, and for a mirror, it is known as the center of curvature. For the mirror, it will be known as center of curvature. Do we understand this? Yes or no?
Yes, sir.
Okay,
Yes, sir.
you can't raise hands because I can't see you. So center of the sphere. Then I can have this R. What is this R? The green one. What?
Radius of curvature.
Yes, this is the radius of the sphere that I have drawn or I have copied. This is the radius of the sphere, and for the mirror, this would be known as the radius of curvature. Do we understand this? Yes or no? So these
Yes.
are the first 2 points that you will write. These are the first 2 points that you will write. The first point is, the first definition is center of curvature. The first definition is center of curvature. And what is this center of curvature? Number one, center of curvature. Center of curvature of a spherical mirror. Remember, we are talking about spherical mirrors. Center of curvature of a spherical mirror is nothing but what? Who will complete the sentence? Who will complete this
Center
definition?
of the sphere.
It is the center of the sphere. It is the center of the sphere of which the mirror is a part, or from where the mirror has been taken out. I hope everyone is able to understand this. Now you may write this definition in English, you may write it in Hindi, Tamil, Telugu, doesn't matter, because you just need to understand this. Once you write the definition of the center of curvature, which is here, you will write the definition of radius of curvature with your own hands. I will just say what you need to write. It's on the same line. The radius of curvature of a spherical mirror is, instead of center, you just write radius of the sphere of which the mirror is a part. Do we understand this? Yes or no?
Yes,
Yes,
sir.
These
sir.
are the two first definitions that you will write. You will also write by which letter are we going to denote these places. So center of curvature will normally be denoted by which letter? If I have to,
T.
yes, if I have to ever tell you the center of curvature, I'll always use the letter C. C stands for the center of curvature unless otherwise stated. I might use C for something else as well. C denotes its center of curvature, and how I am going to denote its radius of curvature?
R.
The radius of curvature would be represented by the letter R. So that is what you will also add here. The center of curvature is normally represented by the letter C, and the radius of curvature is normally represented by the letter A. I'll give you a minute to note these things down. And I hope that you are able to understand what we are writing. And I hope the diagram is quite clear. You can see it on the big screen. Once you are done, let me know so that I can move on to the next definition. We will be writing all these definitions. We'll be keeping coming back hence and forth, here and there, upar and niche. and we will see this. Are you done, bacha?
Yes, sir.
The girls wala class, are we done?
Sir, 1 minute.
1 minute. Okay, I shall give you 1 minute. You have to draw this diagram as beautifully as you can. You may not use a divider or a compass to draw the circle. You can just draw a circle. I just want to show you a good diagram. That is why my drawing is not that good. So I just showed you a better diagram so that you can easily understand them. Can I move on? Life has to move on.
Yes, sir.
We have written, we are moving on to the third definition. But before moving on to the third definition, we must understand how these mirrors are made. So on the first, number A, we have one mirror, and number B, we have the other mirror. One is the concave mirror and the other one happens to be the convex mirror. Do you understand the difference between the concave mirror and the convex mirror? Who is going to tell me the difference between the concave mirror and the convex mirror?
So concave mirror is curved inwards while the convex mirror is curved outwards.
What do you mean by curved inwards, my dear friend? That is correct. Yes, you are right.
The reflection is on the inner side, reflected surface.
The reflected surface, the surface which is going to reflect the rays, is facing the center of curvature, whereas in a convex mirror, it is facing the opposite side. Do we understand this, everyone? Concave mirror. In concave mirror, the reflecting side, let me denote it by the yellow sign, the reflecting side is facing the center of curvature, is towards the center of curvature, but in case of convex mirror, the reflecting side is away or opposite or on the other side of the center of curvature. Do we understand this? Yes or no? No, yes. We understand this?
Yes, sir.
Remember, the laws of reflection are always valid, whether it is a plane surface or it is a concave surface or it is a convex surface or any irregular surface. Also, the laws of reflections are valid. Can anyone tell me what is the law of reflection? There are the laws of reflection that are valid everywhere. And can you see them on the screen now? Can you see them on the screen now? The laws of reflection. This diagram, this arrow has been drawn wrongly. Yes, this is the arrow. Do you see the laws of reflection here? Yes or no? No or yes?
Yes, sir.
Where do you see the laws of reflection?
So angle of incidence is equal to angle of reflection.
Yes, my dear friend, angle of incidence is equal to the angle of reflection. And remember, the angle of incidence and angle of reflection are always with the normal, my dear friends. Now, this is the normal. This is the normal n. I hope you understand the normal n. And this normal n, this angle is 90 degrees. Please remember, this normal n has to pass through the center of curvature because this entire gentleman is a part of a sphere. So whenever you draw a line from the center of curvature towards the mirror, it will always be perpendicular. Do we understand this? Yes or no?
Yes, sir.
Simple things.
Yes,
If you
sir.
understand, the life is going to become very easy. I'm going to draw it on the left hand side because it is not drawn. So I will draw it. Tuck, 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 tuck. This becomes my normal. This gentleman becomes my angle of incidence, and this gentleman becomes my angle of reflection. As you can see, they are not looking equal because the diagram is not to scale, but they have to be equal. Are we getting this point? Yes or no?
Yes, sir.
Please remember these points. Draw these two diagrams. You may not be able to draw them accurately, but just understand the concept. Why I have drawn this diagram is because I wanted to tell you the third definition. And the third definition, the third term is right now on your screen. While you are drawing the diagram, can you tell me what is the third term that we are talking about? The third term that we are going to first understand.
Focus.
No, it's not the focus.
Pole.
Pole of the mirror is the gentleman that we are going to define first. PP, pole, PP. And since you have recognized that we are talking about the pole of the mirror, you must be able to tell me, my dear friends, what is the pole of the mirror? That is the third definition that we are going to do. Number 3, pole of the mirror, represented by the legendary letter P, P standing for pole. What do you mean by pole of the mirror? Pole of the mirror. Yes, my dear friends, I'm waiting for your answer.
Center of the mirror surface.
Yes, that is correct. Center of the mirror surface, or you can also say center of the reflecting surface. This is the center of the mirror or the center of the reflecting surface. You can simply write this, and if you can draw the diagram as well. That will help you in understanding the concept of pole of the mirror. That also takes me to the fourth definition, which I'm afraid is not there. It was there in the previous diagram. So let me. Yes, beta.
Pole is not the intersecting points of principal axis and mirror.
What, beta?
Intersecting point of principal axis and mirror.
Intersecting point of
Principal axis and mirror.
principal surface.
Principal axis.
Principal axis is defined after we define the pole. Do you understand this?
But is the definition correct, sir?
Yes, but see, you have to understand what comes first, the chicken or the egg. You might not be able to say which thing has come first, but here I can tell you which thing has come first. The pole of the mirror has to come first. Are you getting my point, beta? We first need to define the pole of the mirror, and then we will define the principal axis. Am I clear?
Okay,
Yes.
sir.
You cannot define the principal axis first and then the pole of the mirror. No. That cannot happen, my dear friends. You'll have to define the pole first. Pole comes first, then the principal axis. And the order is important because the order in which you understand things is important. Do we understand this? Do we understand this?
Yes, sir.
The order is important. And you have to understand the chronological order. So pole is coming first, then comes the next thing that we were talking about. And do you see this thing? This thing. Do you see this thing? This line? Do you see this line, beta? I might take you to the previous diagram. Do you see this gentleman in blue?
Yes, sir.
That is the next definition, and the next definition is for what? Principal axis. Do you understand the principal axis? Yes or no? No, yes.
Yes, sir.
So that is the next definition, my dear friends, that we are going to write. I hope you have marked it. Principal axis. What is principal axis? Now, please tell me what is principal axis.
Line passing through center of curvature and the pole.
Principal axis. Well, your concept is correct, but the better way to show this, it's the line joining C with P. That is a better way of saying the thing. Line joining what? C and P is the principal axis. What does C stand for, my dear friends? What does C stand for here? Are?
Center of curvature.
Yes, C stands for the center of curvature and P stands for the pole. So once you know the center of curvature and you know the pole, you draw a line joining the center of curvature with the pole, and this line becomes your principal axis. Do we understand this?
Yes, sir.
That is that is the fourth definition, which is the definition of principal axis. Are we noting things down? Yes or no? No or yes?
Noting, sir.
Okay, I'll give you time to note it down.
Done, sir.
Done, sir?
Yes, sir.
Shall I move ahead, sir?
Sure, why not?
Okay. The other class,
Yes, sir.
are we done, beta?
Yes, sir.
Okay. Now, what is the next definition that we are going to write? What is the next definition that we are going to write? The next definition that we are going to write is for the aperture, and let me just clean this up a bit so that you understand it. So I've just cleaned up things. The next definition that we are going to write is for aperture of the mirror. Now, what do you mean by the aperture of the mirror? Have you heard this term, aperture of the mirror? Yes or no? No or yes?
Diameter of the reflecting surface.
Diameter of the reflecting surface. That is absolutely correct, my dear friend. Diameter of the reflecting surface. And if I may draw, and I'll use some fancy lines. Let me see if I can use this fancy line. No, this will not work. So let me just use my simple hands and I draw this line like this. This is the effective diameter of the reflecting surface, and if I can show you the reflecting surface by this legendary color blue, which I love, this is your reflecting surface. This entire blue thing is your reflecting surface, and the red line that I have drawn is the diameter of this reflecting surface. Oh, I have used the wrong color. That is not good. I am very particular about colors because there are only 4 or 5 colors that I understand: red, blue, green, black, brown, pink, orange. That's it. That's my color definition. Diameter. Diameter is the diameter of the reflecting surface is known as the aperture of the mirror. Do we understand this? Yes or no?
Yes, sir.
That is the next definition, my dear friends, that you will write. I just had to move the screen a bit. I hope you have drawn that diagram. I will write definition number 5. Definition number 5 is the aperture of the mirror, and the aperture of the mirror is nothing but the diameter. Remember, in the exam, beta, they will not be using the term diameter of the mirror. They would be using the term aperture, and that time, please remember the diagram, and that is why the diagram becomes very important. Aperture of the mirror is the diameter of the reflecting part. I hope everyone is there with me. Yes or no? No, yes. Everyone is noting things down.
Yes, sir.
Yes, sir. No, sir. Better I do, sir. What is the next definition, my dear friends, that we are going to discuss? And let me just clear the code here before we begin our next adventure. Yes, bacha. What is the next definition that we are going to see or understand? It's right now on your screens. Yes, my dear friends. What is the next definition that we are going to do? We have seen C, we have seen P, we have seen M dash and M. This gentleman was M dash. May not be looking evident to you, but this gentleman is was M dash, M dash M. Yes. What is the next definition that we are going to do, my dear friends?
F, sir.
F, sir. Yes, sir. F, sir. What is F known as? Here, the red one or the green one. They are doing the same thing, but they're doing it differently, somewhat differently, maybe. Yes. What does F stand for?
Focal point.
Focal point. Okay, not wrong. Not entirely correct. It's correct,
Focus.
not entirely correct. Remember, physics is all about the right terms and definitions and understanding. Yes, what is F?
Focus.
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 Principal focus. Will you remember?
Principal focus.
Yes. Be very peculiar about the term and the right term. The right term is principal focus. So please write the next point, principal focus. But before writing the next point and the definition, can you tell me how are you going to define this principal focus? What is principal focus? Now, the definition might look a bit different for concave mirror and convex mirror. As you can see, in concave mirror, it is looking slightly different. And in convex mirror, it is looking slightly different. But the meaning is same. What is the definition of principal focus denoted by the letter F, written in yellow and green? Yes. Yes, my dear friends, what is the definition of principal focus? You know it. I know it that you know it. I know it that you know it, so don't worry. You know it. Yes, bacha. I can't hear you. Sorry. Can anyone help? What is principal
Half of
focus?
the center of curvature.
No, that is definitely not the case. Sorry.
Midpoint of principal action, central curvature.
No, that is the same thing as saying half of radius of curvature. That is not the right definition.
Sir, a point where all reflected lines pass through.
When? When? When?
After reflection.
After reflection. What type of?
Light rays are parallel to the principal axis.
Yes, that is the correct option. Now look very carefully. Look at this yellow. Look at this green gentleman. This green gentleman is my incident ray. Now this incident ray, as you can see, is parallel to the principal axis. Do we see these two lines parallel? Yes or no? No, yes.
Yes, sir.
Now after reflection, which I shall draw by this gentlemanly blue, still remains green. It should become blue. Yes. After reflection, this blue gentleman, which is the reflected light, is passing through this focus, and this is how principal focus is defined. Rays of light which are parallel to the principal axis, after reflection, they pass through a point on the principal axis. That point is known as principal focus. So it is the point of intersection of reflected rays when the incident rays are parallel to the principal axis, the point where these reflected rays meet, or the point through which these reflected rays pass on the principal axis, that gentleman point is known as the focus. No, not the focus, the principal focus. Do we understand this?
Yes, sir.
Now, in case of
Yes, sir.
concave mirror, that is the definition. In case of convex mirror, the definition is somewhat different because they do not actually pass through the principal focus, they appear to come from the focus. So that is the only difference. The green light is the incident light, which is parallel to the principal axis. After reflection, this light passes in this direction like this. It does not actually pass through the focus, but it appears to be coming from the focus. So for the convex mirror, the definition looks somewhat different, but it means the same thing. It is a point of intersection, or it is a point from which reflected ray seem to appear when the incident rays are parallel to the principal axis. That point on the principal axis is known as the focus or principal focus of the convex mirror. Do we understand this? Yes or no? No, yes.
Yes, sir.
That is the definition of principal focus. First, I will show you a quick snap, and
Your slide got stuck.
no, my slide did not get stuck. The slide never gets stuck. It only gets stuck because I order it to get stuck. That is the only way it can get stuck. Okay. So this is the diagram that will make you understand the point that I was saying. If you can draw this diagram in rough, that is great. So in diagram number A, what is happening is incident rays, the blue rays are parallel to principal axis, and after reflection, they are passing through one point on the principal axis. That point is known as the focus. If you say it in the reverse way, if a ray of light passes through the principal focus, after reflection, it will become parallel to the principal axis. Do we understand the difference in point A and point B? Actually, point B is the reverse of point A, or point A is the reverse of point B. Do we understand this? Yes or no?
Yes, sir.
What happens in case of a convex mirror? As you can see here, the incident rays are parallel to the principal axis. After reflection, they will just go away like this. They actually do not come from the focus, but they appear to come from the focus. If I reverse this, that means a ray of light which is trying to go to the focus, it is not actually going to the focus. After reflection, it becomes parallel to the principal axis. This entire chapter is about drawing diagrams correctly and understanding the terms. As I have told you, the question that came in JEE of this year, where 3 mirrors were put in the form of a triangle, was all about drawing diagrams. You could have drawn the diagram, that question could have been done in less than 40 seconds. It's all about drawing the diagram. Do you understand this, bacha, what I am talking about? Do you understand the
Yes,
4
sir.
diagrams? Yes or no? Once you draw this diagram, then I will give you the definition of concave mirror and convex mirror ka principal focus. Just draw these diagrams. Whatever best you can draw it. If you understand it from figure A, you may not draw figure B, because figure B is just the reverse of it. So you may just draw figure A, and you may just draw figure C. You need not draw figure B and D, because figure B and D are actual opposite of this. In figure A only, you can do the same thing. Instead of drawing the line like this, you can draw the line from here, and the two figures are same. Do we understand this? Yes or no? Okay. Once you are done, we will write the actual definition of this principal focus. Once you are done, please let me know, beta. As I said, diagram B and D are not important. If you understand A and C, that is more than enough.
Done, sir.
Done, sir?
Done, sir.
Then write the definition of principal focus. Please write it. Principal focus. Principal focus denoted by the letter F. It is the point of intersection. It is the point of intersection of incident rays that are parallel to PA. Do you understand the meaning of PA? Do you understand the meaning of PA? Oops.
Yes, sir.
What is that PA, bacha?
Principal axis.
Right. So I'll be using these terms and I hope that you understand this. Principal axis. For concave mirror, it is a real point. For convex mirror, it's a virtual point. Do we understand this?
Yes, sir.
Remember, these small points is where the difference is. Now, is this definition valid for all types of mirrors? That is where they will confuse you in a JEE, not in NEET and JEE Main, because NEET and JEE Main are simple exams of 11th and 12th standard, even lesser than that level. Because in 11th and 12th, you have to write the paragraph questions and all these. These are just take and mark and go away. Now remember, this definition where the rays are meeting, the parallel rays are meeting, is only valid if the mirror is of small aperture. The mirror has to be very small. Now in diagrams that we draw, the mirrors are very big. But remember, whatever questions we are doing in ray optics in this chapter, they are always, if not mentioned, are mirrors of small aperture. Will you remember this?
Yes, sir.
Because if the aperture becomes more, the rays will actually not pass through the center or pass through the focus. They will not pass, and I will do a question of this nature where they will not pass, and you have to find out from where they pass. So remember, this definition is only valid for this definition is only valid for
Mirrors with small aperture.
this definition is only valid for mirrors of small apertures. It's only valid for mirrors of small apertures. Remember this. This is strictly for JEE Advanced. In NEET or Mains, they may ask, is this definition? But they will not be making a question on this. They will just ask the theoretical aspect of it. Principal focus. Now remember, for a concave mirror, this is a real point because the rays will actually meet. But for a convex mirror, it's a virtual point. The rays do not actually meet, they appear to come. Do we understand this?
Yes, sir.
Yes, sir. Then, sir, please note it down, sir. Then, so that we can move on to the next definition. And what is the next definition? Anyone has any idea what is the next definition? Remember, I'm trying to take down all the definitions that are possible so that any term that comes in the exam, you will not be bamboozled by it. Because that is the only way they can deceive you in this particular topic. Otherwise, there is nothing in this topic that can confuse you. Only the terms that can confuse you. What is the next definition? Number 7. Anyone, any idea? Number 7. I was writing number 8. Number 7. What is number 7 then? is the definition of the focal plane. What is the definition of the focal plane? And the answer lies in the diagram as well as in the name of this particular thing. What is focal plane? It's simple. What is focal plane?
Plane on which the principal focus is present.
Yes. A plane which contains the principal focus and it must be perpendicular to the principal axis. Because see, this is principal axis and this red point is, let us say, my focus. I can draw an infinite number of planes which pass through this point. Yes or no, beta?
Yes, sir.
Which plane? The plane which is perpendicular to the principal axis. Do we understand this? So focal plane is a plane which contains the focus and it is perpendicular to principal axis. Plane containing, and that's why I've drawn the diagram. Plane containing principal focus F and it is perpendicular to CP. Do you understand the meaning of CP?
Yes, sir.
What is CP? Line joining C with P, and that is your principal axis. That is definition number 7. Focal plane. I hope everyone is drawing. You may not draw the 2 diagrams. One diagram is good enough. That makes you understand this. I have just drawn all what is there so that you don't get bamboozled in this particular thing. Because remember, beta, the only way they can fool you in this particular chapter is by what? Is by the definition of these things. Now, one more thing I wanted to show you, so I'll just put it on the screen. Because I have seen questions of this coming. So again, my entire concentration is to get all the information that is possible and put it to you so that you can use the best of this information for the questions that are going to come. So, have you noted down focal plane, beta?
Yes, sir.
Then comes the next thing, which again will come maybe a question, maybe as a question. Question number 8, point number 8, parallaxial rays. Parallaxial rays. Most of the question that we are going to do, remember there will be 2 things that may be mentioned or may not be mentioned. The rays, number 1, are parallaxial. The aperture of the mirror is small. Do we understand this? They will be saying this in the question. Rays are parallaxial and the aperture of the mirror is small. Do we understand this, beta? Do we understand this?
No, sir, not properly. Could you repeat it?
The first point they will say is rays are parallaxial. We don't know what is parallaxial rays. We are going to understand this. The second point they will say is the aperture is small. We remember small aperture. Aperture is the diameter. It has to be small. The mirror has to be small. Do we understand this?
Yes, sir.
And the rays are parallaxial. Now, what do you mean by parallaxial rays? I have drawn the diagram and I have drawn the angles here. And parallaxial rays, parallaxial, parallel, paraxial, parallel, something like parallel. Now, these are the rays which are not parallel actually, which has very small what? It's there on the diagram. Tell me, very small what?
Angle, sir.
Angle of what? Is there in the diagram, beta? I want you to understand it from the diagram. It's there in the diagram. It says very small what?
Angle of reflection.
Ah! Angle of reflection is not shown in the diagram.
Angle of incidence.
Yes. Now you will say, sir, if the angle of incidence is small, sir, angle of reflection would also be small. Yes, you are correct. But what is drawn in the diagram is not the angle of incidence, but the angle is not the angle of reflection, but the angle of incidence. So basically, parallaxial rays means those rays which have very small angle of incidence and they are very close to the principal axis. Do we understand this?
Yes, sir.
Parallaxial rays, the diagram tells us all, they have very small angle of incidence. I hope the point becomes clear. Parallaxial rays are rays which have very small angle of incidence. Most of the question that you are going to do, and in JEE Main and NEET, they may not even say it's parallaxial rays, but in JEE Advanced, they might say rays are parallaxial because there is one more type of ray which is not parallaxial. I hope you have written this. Yes or no? No or yes?
Yes, sir.
Then the next type of ray which is not parallaxial, what is it known as? And I've seen a question of this nature come in a JEE paper, that was JEE Advanced. I don't remember the year. I will try to find out that question, and it makes somewhat difference when you talk about this one, and that is your point number 9, and your point number 9 is marginal rays. Marginal rays. Now can you tell me what do you mean by marginal rays?
Angle of incidence is very large.
Yes, the angle of incidence is very large. The angle of incidence is very large. Those are known as marginal rays. And I have seen a question in JEE Advanced on this, and everyone thought that they are parallaxial rays, and everyone did a mistake. Marginal rays are rays, incident rays, which has a large angle of incidence. Do we understand this? Yes or no? No or yes?
Yes, sir. Understood.
Well done. Well done. Well done. So please, you may not draw the diagram, just write marginal rays. I just wanted to show you with the diagram, nothing else. Marginal rays are rays where the angle of incidence is large, nothing else. Have you written marginal rays, beta? You just
No,
write
sir.
angle of incidence is large. That's it. You may not draw the diagram. Diagram is irrelevant here. Just write angle of incidence is large, nothing else. Shall we move ahead in life?
Yes, sir.
Then important points, and everyone knows this, so I will not say anything, and I'll just write this. I hope everyone understands this. Remember this. Oh, I forgot one definition. So I'll write that definition first. That is definition number 10, and the definition number 10 is focal length. Definition number 10 is focal length. So I'll just write it here. Number 10, focal length denoted by the letter F. What is the focal length of a mirror? Yes or no? Please tell me. I just forgot it. I should have told you after focus. Small mistake. Yes. What is the focal length of a mirror? Anyone?
The distance between focus and pole.
The distance between focus and pole, that is absolutely correct, my dear friends. And I might take you back in the past. I have a time machine and I'll take you back in the past. And this is where it comes. This is F. This is P. The distance between F and P is known as The distance between F and P is known as the focal length of the mirror, denoted by the small letter F. Do we understand this? Yes or no? No, yes, I missed it. I should have
Yes, sir.
given you
Sir.
this definition after the focus. Yes. Yes, bacha. After focus, I went to focal plane. So I missed that entire part. Focal length of the mirror F is the distance of the focus from the pole of the mirror. FP is known as the focal length. Do we all remember this? Do we all understand this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, sir?
Yes, sir.
Okay. So please note this down. Focal length F is the distance of the focus from the pole of the mirror. And now I will just write. It is nothing but focal length F is nothing but the distance of focus F from the point P. So it is FP. Focal length is FP. And since I've written what is focal length now, now you can understand this point number 1. F is equal to R by 2. The focal length of the mirror is radius of curvature divided by 2. And again, this is only valid. This is only valid for what? This is only valid for what?
Small apertures.
And and small apertures 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 and no one knows the answer. Paraxial rays. Will you remember it?
Yes, sir.
Most of the question that you are going to do will be on small apertures and parallaxial rays. If the aperture becomes large, it may not pass through the principal focus and the principal focus will not be R by 2. And if the angle of incidence also becomes large, my dear friends, they will not pass from the focus. They pass through a point. We will call this as focus. But remember, it will not be R by 2. Do we understand this?
Yes, sir.
The definition is valid, but remember, the formula is only valid for small apertures and small angle of incidences. Do we understand this, bacha?
Yes,
So this
sir.
formula that we have written, and that is why it is important for you to understand where it is valid. It is valid for small apertures and parallaxial rays. Shall I move on to the next point? Yes or no? No, yes.
Yes, sir.
Now, the next point again, which will be asked in probably JEE Main, NEET, I mean all the 3 exams, because this is just a knowledge-based question. This might come more in the chapter of wave optics probably, but I can obviously devise a question here. And there was a question in JEE Advanced where they had blackened the surface and something has happened. That is why I'm giving you this point. The intensity of image, how sharp your image would be. Intensity. Do you understand the meaning of intensity? How sharp is your image? Intensity of image is directly proportional to the area of the mirror and therefore it is proportional to the aperture square. Will you remember this? How intense would be your image? If I make the radius or diameter half, the area becomes 1 by 4 times and your intensity becomes 1 by 4. Do you understand this? Will you remember this, beta?
Yes, sir.
That the intensity of the image that is being formed, it depends on how much is my area of the reflecting surface, and therefore it is diameter ka square. If I make the diameter twice, the intensity of the image becomes 4 times. And that is why to see all these distant stars, you build big telescopes. You know big telescope. Why big telescope? Big apertures. Why? The more the aperture, the area becomes square of that, and therefore more light comes and you get good images. Do you understand this? Or it has gone above our heads?
Yes, sir.
And right now we have this James Space Telescope, just sending you incredible images. Why? Because first of all, it is in space, and secondly, it has got a large aperture. And that is why it can see galaxies which were not seen. Yesterday only, they have discovered a planet, not a planet. They have taken a direct picture of a planet, and that was not done before. We know there are 3,000 or 4,000 planets that we have discovered, but we have discovered them by the intensity of the light. We are studying whatever wavelengths are coming outside the solar system. We had not taken picture of an actual planet. I think 20 such instances had happened, but just yesterday, the James Webb Telescope actually took a picture of a planet, and that is something really great. Why I'm telling you all this? Aperture. The bigger the mirror, the more is the intensity of the image, and you can see the vast universe around you. Do we understand this? Yes or no?
Yes, sir.
Yes,
So
sir.
this is what we are going to finish the class on, and I shall give you a small homework. Yes, beta? Yes, beta? Any problem? Any doubt?
No, sir.
Yes, I shall give you a small homework which I know that you already know, and that is why I just share a snapshot. We will discuss this snapshot in the next class, but right now I'm just giving you because I know that you know it, and you can probably do it on your own. Which is ray diagram. Have you gone through ray diagram? Yes or no? No, yes. We'll have to draw ray diagrams, and there are only 3 rules that you might follow to draw a ray diagram. Actually, there are 4 rules. Actually, there are infinite rules, whatever. Rule number 1, rule number 2, rule number 3. And out of these 3, you can only use 2 rules. Get 2 rays because you want to intersect. Therefore, 1 ray will not do. So you will have to take 2 rays so that you can get an intersection point. And from that intersection point, we will be able to find out where the image is going to be formed. Yes or no? No, yes.
Yes, sir.
Can anyone tell me what is rule number 1, what is rule number 2, what is rule number 3? Looking at the diagram. Quick, 1 minute answer. How are we going to trace ray tracing, ray diagram, ray drawing? Answer is on the screen. Can anyone tell me what is the answer? How do we trace
So
it?
when the incident ray is parallel to the principal axis, the reflected ray passes through focal point.
That is rule number 1. Rule number 2.
When the incident ray passes through the focus, the reflected ray is parallel to the principal axis.
So that is the reverse of rule number 1. Yes or no?
Yes, sir.
Rule
Yes,
number
sir.
3. Rule number 3.
When the incident ray passes through the center of curvature, it reflects in the same path
Why?
because it is the shortest path.
No.
Angle of incidence is equals to angle of reflection.
And how much is that?
0.
0. That is why it comes back. That is why it comes back. So these are the 3 rules, and we will discuss these rules. We will write them, and if you can do it on your own, I would be pretty happy because we will be saving some important time here. So we'll discuss these 3 rules. We'll also discuss rule number 4, which is any ray, if you draw whatever should be the angle of incidence, the same would be the angle of reflection, because that is a raw reflection that is right everywhere. And I will finish this class here at this point in time on a high note. We have made some progress in today's class. We just need to be a little more And that is the only thing that we need right now. But what we have covered today is quite good, considering the amount of things that we have done. In the next class, we will be moving ahead with spherical mirrors. We will be seeing some ray diagrams, and I will be giving you cases where the object is and where the image is formed. You will have to remember them. And I hope you remember them because we have done it in 10 standard. So I'll meet you tomorrow. If you have any doubts, you can always ask me. Take care. Have a good day. Bye bye. God bless
Thank you,
all
sir.
of you.